Hi, this is Mrs. Wiederholt, and welcome to my lesson video on Introduction to Polynomial Functions. Now let's get started. Well, first you might be asking yourself, what are polynomials? We've been using them all year, but we've really never talked about the word. And so poly simply means many, and then nomials means terms. So polynomials are simply just many terms. Now, what does it mean when we say the degree of a polynomial? Well, the degree of a polynomial is the highest degree of its terms. So, for example, if we had a polynomial that was x squared plus 2x to the fourth power plus 3x, we would say that this is a polynomial to the fourth degree, because the largest exponent of the three terms is a 4. Now we need to understand what it means when we say the degree of a term. Not the degree of a polynomial, but the degree of a term. It is the sum of the exponents of its variables. So if we use the example of 3x to the fourth times y to the third, we would say that this term has the degree of 7, or we would say it's to the 7th degree, because you add the exponents of both of the variables. Finally, we need to understand how to write a polynomial in standard form. Now, this is the form where the terms are ordered by degrees. So let's look at our example up here. I have this trinomial. It's a polynomial made up of 3 terms. That's why it's called a trinomial. And if you notice though, my first term has the exponent of 2 and my second term has the exponent of 4. So if I want to write this in standard form, I need to put the term with the largest exponent first. So I would write this as 2x to the fourth, and then my next term would be x squared, and then my next term would be 3x, because the 3x has x to the first power. So writing it in standard form simply means putting your exponents in numerical order from greatest to least. Now let's look at an example. In this example, we will be looking at and deconstructing 2x squared plus 10x plus 8. First, let's write down each of the terms. Our first term is 2x squared. Our second term is 10x. And our third term is 8. Now, terms are always separated by an addition or a subtraction symbol. And a term may consist of a constant, or it may consist of a coefficient with a variable, or it can just be a variable. Next, let's write down our exponents. Now, our first term has the exponent of 2, and our second term, we don't see an exponent. That means it's invisible 1. Now, you might be asking me, why do I have a third space? Because what you may not realize is a constant actually is multiplied by x to the 0 power. Now we know anything raised to the 0 power is equal to 1. Therefore, we would have 8 times 1, which equals 8. So even though we can't see it, we need to recognize that 8 is multiplied by x to the 0 power. Next, let's write down our coefficients. So remember, a coefficient is the number in front of the variable. And then 8, because we don't see x to the 0 power, is going to be a special type of coefficient. So here we go. Our first coefficient is 2. Our second coefficient is 10. And we can say the third coefficient is 8. But when you have a number and you do not see a variable, we call that number the constant. So 8 is going to be called or referred to as the constant. Now, what is the degree of this polynomial? And as we stated on the page before, we look at the largest exponent of the polynomial, and so we would say that this has a degree of 2. We would also refer to it as a second degree polynomial. Now, every polynomial has a leading coefficient, and that is simply the coefficient of the first term in the polynomial. So our leading coefficient for this example is 2. Now let's look at some expressions and identify the type of polynomial, their degree, and the leading coefficient of each one. First, let's look at the expression of 9. Now remember, we just talked about when we see a number by itself, we know that it is a 0-degree polynomial. Okay? 9 is multiplied by x to the 0 power, which we said is 1. So 9 times 1 is 9. So we don't see the degree, but it's there to the 0 degree. Now, because this is one term only, this polynomial is classified as a monomial because it has one term. And as we've just stated, the degree is 0. And the leading coefficient, well, this is a constant, so the leading coefficient is the constant. Now let's look at x minus 2. Well, the x is to the first power, so we would say that this is a first-degree polynomial. And even more specifically, since there are only 2 terms, this polynomial is classified as a binomial because it has 2 terms. The degree is 1, and the leading coefficient is invisible 1, the invisible 1 that's in front of x. Now let's look at 3x squared plus 4x minus 5. Well, our largest degree is with the exponent of 2, so this is a second degree polynomial. And because there are 3 terms, this is classified as a trinomial. The degree is 2, and the leading coefficient is 3. Now, I want you to pause the video, and I want you to try the next 3 expressions. See if you can tell what type of polynomial it is, to what degree it is, and its leading coefficient. So after you've done that, press play, and you can check your answers. Okay, so how did you do? Well, let's look at 4x to the third minus 6. It's to the third degree because of our exponent is 3, and it's 2 terms, so it's a binomial. The degree is 3, and the leading coefficient is 4. Now, let's look at this one right here. This one's interesting. We actually have 5 terms, and when you have more than 3 terms, we usually just refer to it as a polynomial. We no longer distinguish or classify it by its terms, monomial, binomial, trinomial. So after 3 terms, we will just refer to everything as a polynomial. 4 terms, 5 terms, 6 terms. And then, of course, we have it's to the 4th degree. The degree is 4. The leading coefficient is 7. And then this one, x to the 5th power, that's a 5th degree trinomial because there are 3 terms. The degree is 5, and the leading coefficient is 1. Now let's talk about this last expression. We have 6x to the 4th times y squared times z. Now, this would be a 7th degree monomial. Now, it's 7th degree because remember, we've determined the degree of the monomial. If there are different variables, we take the sum of the exponents. And in this case, we have an exponent of 4, an exponent of 2, and an invisible exponent of 1. So 6 plus 2 plus 1, 4 plus 2 plus 1 is 7. So the degree is 7, and the leading coefficient is 6. Now, I hope this video has helped, and remember, you can always rewatch it, you can pause it where needed. I look forward to working with you again. Bye-bye.